Thank you for joining this lesson. We're going to discuss physics paper 2, electrostatics, number 14, part A. Define the following terms. The first term is a capacitor. The capacitor is simply an electrical device used to store energy in form of electrical charge. In terms of or in form of electrical charge. The second term is capacitance. So capacitance is the charge stored per unit voltage, or the ratio of the charge which has been stored divided by the voltage across the plates of the capacitor. So that's why we say charge is capacitance, is usually given by charge out of V. From this formula, I usually say Q, charge, is equal to CV. So that is the definition of the two terms. Let me check the third part, or part B in this case. 3 capacitors are connected to a 10-volt battery, just as shown on the diagram. Then we are told, part A, to calculate the effective capacitance. Capacitance, when in series, like we can see the 4 microfarad and the 5 microfarad capacitors, which are in series, is usually given by the 1 out of total capacitance equals to 1 out of the first capacitance plus 1 out of the second until you add all of them. That is for the case of the series connection. But now in our case, they are only 2. So 1 out of capacitance total will be 1 out of 4 plus 1 out of 5. So 1 out of C total equals to 1 out of 4. Let me compute this. 1 out of 4 plus 1 out of 5, giving us 9 over 20. 9 over 20. So now we can get capacitance total by taking the reciprocal. So the reciprocal here will be capacitance total. So 20 out of 9, which is equivalent to 2.22 microfarads. So for the 2 capacitors in series, the capacitance is 2.22 microfarads. Then now we have one capacitor, the 3 microfarad capacitor, such that we are reducing now. This is 3. Then now on the lower side we have reduced the 2 capacitors into 1 capacitor. The equivalence of 4 and 5 in series is equal to 2.22 microfarads. So we're going to have 3 now on this part, such that now, because they are 2 and in parallel, when they are in parallel, total capacitance is usually given by the sum of the individual capacitances. So C1 plus C2 plus C3 all the way up to the N, as long as they are in parallel. So you take the first one plus the second one. So that you say capacitance here will be 5.22 microfarads. So this is the effective capacitance according to this question. 5.22 microfarads. Then another question is asking us to find the total charge in the system. According to my question there, I had already said that a charge is usually given by capacitance times voltage. So for us to get charge, the total charge, then we need capacitance total in the system times the voltage, and this will be 5.22 multiplied by 10. So this is going to give us, the voltage is 10 according to the diagram and the instructions. So 52.2, but it's good to know that the capacitance should be converted to SI units. It's already in microfarads, so we can multiply times 10 power negative 6, and now we multiply by the voltage of 10. So the first 10 power negative 6 is to divide it by a million, so that the capacitance is in SI units. So these are now farads. This is capacitance now, but in farads. Capacitance in farads. Therefore, it's going to be 5.22 times 10 power negative 5, because it is charge, now coulombs. It's good to master that. Capital C is a coulombs, abbreviated units of charge. And again, capital C is capacitance. According to this formula, C is for capacitance, but in this answer, C is for coulomb. Part C, state 3 factors that determine the capacitance of a capacitor. The first one is a distance of separation between the two plates. Distance of separation. The other one is what we call area of overlap. Area of overlap. Then the last one is the dielectric material. The electric material used in between. This is the insulator now. In between. The insulator in between the plates. It's what we call the dielectric material. Those three are the factors affecting the capacitance of a capacitor.